Our today's topic is nature of CX bond, right? We are studying haloalkanes and haloarenes, and in both these classes of organic compounds, we'll have a bond between carbon atom and X atom. X is the halogen atom, chlorine, fluorine, bromine, or iodine. Let's today study and try to understand what is the nature of this CX bond, right? If we have to represent this bond, it will be represented like this. Carbon की valency 4 होती है, 1, 2 and 3. Now, there's an electronegativity difference between the two. The bond is a covalent bond between carbon and halogen atom. The bond formed is a covalent bond. However, there is an electronegativity difference. And what is that difference? We know that electronegativity of X halogen atoms is greater than that of carbon. Fluorine, in fact, is the most electronegative element of the periodic table. लेकिन सभी halogen atoms की electronegativity is more than carbon, right? Because of which your shared pair of electrons hai, it will be more towards X, and due to which X will have a slightly negative charge on it and carbon will have a small positive charge on it. So that if we have to write down the description about the nature of this bond, we can say that this CX bond between the carbon atom and the halogen atom is polar in nature, right? It is polar in nature. Since it is a polar bond, it's a polar molecule as a whole, it has a dipole. It has a positive pole and it has a negative pole, right? Now what happens here is, we spoke about X, the general symbol for halogen atoms. But our halogen atoms can be a fluorine atom, it can be a chlorine atom, it can be a bromine atom, or it can be an atom of iodine. And down the group from fluorine to iodine, if we speak of size, what happens of atomic size? It increases, so that iodine जो है सबसे बड़ा है. After that we have bromine, after that we have chlorine. And size of the atom will obviously affect the polarity of the CX bond, right? Because we are speaking about the dipole. This is the delta positive, this is delta negative. And what is dipole? Mu is equal to Q into D. Charge, magnitude of charge, either we can take negative charge or positive charge, into D, distance between the positive pole and the negative pole. So that D will be automatically affected by the size of these atoms. Therefore, there will be an impact of this order of the atomic size of halogen atoms, right? Now, since this size increases from fluorine to iodine, if we see the impact first on the bond length. What will be the bond length? सबसे बड़ा bond कौन सा होगा? Carbon iodine bond with the other three valencies of carbon. This will be bigger than carbon bromine bond, which will be bigger than the carbon chlorine bond, and which in turn will be bigger than the carbon fluorine bond. Right? And in class 11th, when you must have studied the bond parameters, chemical bonding में, आपने देखा होगा कि bond length and bond dissociation energy, they have a relationship. What is that relationship? It's an inverse relationship, right? If iodine is the biggest, Ci bond is the longest bond of all of these bonds. Therefore, it will be the weakest. And if next we have to write down the order of the bond dissociation energy or the order of the strength of the bonds will be in this order. Cf greater than CCl. I'm not writing down all the other three valencies of carbon, it's understood. After that, we should have CBr, and after that we should have CI. So I've given you three rows, three different orders, because the order of the atomic size is this will be the order of the bond length, and this will be the order of the bond dissociation energy. However, after knowing this order, you do understand that if we speak of electronegativity ka variation down the group, this is our halogens, fluorine, chlorine, bromine and iodine. Fluorine is most electronegative element of the periodic table, not only of this group, but it is the most electronegative, highest electronegativity fluorine की होती है Pauling scale पे, which is 4. And from top to bottom in a group, what happens is that electronegativity decreases. Right? Electronegativity decreases. Since it decreases from top to bottom, if we have to speak about the order of polarity of CX bond, as per that data, this bond should have been, the order of polarity should have been, CF should have been the most polar. More polar than CCl bond, which should have been more polar than CBr bond, which should have been more polar than Ci bond. This should be the order of the polarity. It is in general a polar bond, but when you change your X, what should be the order? This should be the order. But it is not so. Right? When we study the polarity of CX bonds, what we observe is the correct order is CCl bond is the most polar bond. After that we have CF, after that we have CBr, and after that we have Ci. And it is very important to remember this order. Why is the change here? Why this change here? In spite of the fact that F is the most electronegative element not only of the group but of the periodic table, we cannot ignore the other property of fluorine, that fluorine atom has a very small size. Its atom is very small. And as I said in the beginning, polarity किस पे depend करती है? Dipole moment पे. And that dipole moment is Q into D. Anything that affects D or affects Q will affect the value of mu. No doubt it is highly electronegative, but because of its small size, CF bond is slightly less polar than CCl bond. Right? What happens because of the small size? The distance decreases. The distance between the two poles decreases, consequently decreasing the value of mu. Right? Again, take a look at this and remember this order. The above given order is not the correct order. This is the correct order. Right? And if you want to remember the data, I'll just quickly give you some data of the polarity of these bonds. Right, we have a CF bond. We'll take as the methane derivatives, methyl fluoromethane, and then we'll take CH3Cl, we'll take CH3Br, and we'll take CH3I. Fluoromethane, chloromethane, bromomethane, and iodomethane. Right? If we have to write down the values of mu, values of dipole moment, they are like this. CF bond is 1.847 dBi. You have studied dipole moment in class 11th. CCl bond is 1.860. There is a slight rise, but there is a rise. This is 1.84. This is more than it, 1.86. After that, we have CBr, which is 1.830. After that, we have finally CH bond, which is only 1.636 dBi. And if you see the order, what is the order? 1.860. First comes chlorine. After that, we have fluorine. After that, we have bromine, and after that we have iodine. Therefore, this is the order. CCl bond has the highest dipole moment, then CF bond, then CBr bond, and then Ci bond. This is everything you need to know about the nature of CX bond in haloalkanes and haloarenes.